Hello everyone, welcome to my channel. Today we are going to derive shape functions for bar element first and then for the rectangular elements using the Lagrange method. First of all, let's look at the bar element. So talking about the shape function derivation using Lagrange method, there is a very easy method for deriving the shape function. For example, let's say we are in a local coordinate system of xi because it is uniaxial, and coordinate in local coordinate for node 1 is xi1 here, and for the node 2 is xi2, and at any intermediate point we have xi as local coordinate. So now we need to derive the shape function for the node 1 and node 2. So according to Lagrange method, if you have to find the shape function for node 1 and 1, then there is a very simple formula. So you just do xi minus, since you are looking shape function for node 1, now you subtract with this coordinate, second coordinate. So xi minus xi2 divided by, now at the denominator you just subtract xi1 and xi2. So xi1 minus xi2, then this would be your shape function for node 1. So for node 2, you just do the similar thing. Now we are deriving the shape function for this node. So you are going to subtract this xi with this xi1. So xi minus xi1 divided by, now what you are going to do is xi2 minus xi1. So let's just check our shape functions. So we derived the shape function n1. Now we are going to check. For example, the value of shape function at node 1, n1 should be equals to 1. So here if we say, okay, at at node 1, what is the value of xi? Xi is equal to xi1, right? So if we put in this formula, what we get is xi1 minus xi2 divided by xi1 minus xi2, and it results in 1. So it's okay. Similarly, if we check here, the value of xi at node 2 is, what is xi at node 2? It's xi2. So we just substitute in this formula, then we get xi2 minus xi1 divided by xi2 minus xi1, and it's 1. Okay, so we derived the shape functions correctly. Okay, so what does it mean? So what does it mean? What does it mean? For example, let's say we have a bar element and our local coordinate system is from xi equals to 0 to xi1 equals to 0 to xi2 equals to 1, and we know the displacement at xi1 as u1 and at xi2 as u2, and we are asked to find the displacement at this point, right, u. And we just say, okay, the xi here is xi, this is just the local coordinate, and let's say I keep here xi is 0.7 in local coordinate as it ranges from 0 to 1. So using the formula that we derived here, n1 and n2, what you do is you find n1 and n2 by keeping xi equals to 0.7. Then you can find displacement quite easily. Then we can find displacement at xi equals to 0.7 using formula displacement equals to n1 u1 plus n2 u2. So this is the sole purpose of finding the shape function. so that we can find displacement at any intermediate point like here. Similarly, we do this for three-noded bar element. So if we have to find the shape function n1, then we simply do xi, which is basically this, minus, since we are finding the shape function for this node, we are going to subtract second and third. So xi minus xi2 multiply xi minus xi3. Now you are doing for n1, so you just put here xi1 minus xi2, and here xi1 minus xi3. Okay. Similarly, for node 2, what you do is quite similar. Xi minus, now it's not xi2, it's xi1, and xi minus xi3 divided by xi2 minus xi1, xi2 minus xi3. Similarly, for n3, we do xi minus xi1, xi minus xi2 divided by xi3 minus xi1 and xi3 minus xi2. So just for checking, at node 1, value of xi is xi1, right? So if you put in this formula, what you get is xi1 minus xi2 multiply by xi1 minus xi3 divided by xi1 minus xi2 xi1 minus xi3. So what you get here equals to 1. So it's okay. So you can do the similar checks for this one and this one also, and all of it will come 1, 1. And here also, the solve purpose is, for example, if you are given a task to find the displacement at this point, then at first your local coordinate system may be defined anyway. You know, the local coordinate system might range from -1 to +1, or it might range from 0 to 1, and then you just need to find the coordinate at this point in local coordinate. And then you just put the value of xi as your local coordinate and then find the displacement using formula u equals to n1 u1 plus n2 u2 plus n3 u3. And this is the ultimate advantage of finding the set function. So we are going to extend the bar element concept for this 4-noded and 9-noded Lagrange element. Basically, Lagrange element is the element in which there are the nodes inside the element as well, not only in the boundary. If the nodes are only in the boundary, for example, if it was not inside, then this element here, the 9-noded element, would be a serendipity element. But here we have intermediate node also, so it's Lagrange element, while this element can be considered Lagrange as well as serendipity because we can derive the shape function using Lagrange concept as well as serendipity concept. But first, let's look how we can derive shape function using Lagrange concept. So for example, in this situation, we have the local coordinates in xi and eta, and our point of interest is point P, for which we have to find the displacements. So first thing we need to do is find the shape functions for all these nodes. So let's see, if we need to find the shape function for node 1 and 1, then the similar concept we use. So here, since it is a 2D element, we have to consider in both xi and eta direction. So first, let's look at the xi direction. So for this node, node 1, the direction we are going to watch is along this path for xi, okay? This path for xi, and along this vertical path this path for eta. Okay, so let's look at xi coordinate. So n1 is given by xi minus, so along xi direction we are going in this direction, so xi minus xi2, because we meet at node 2 in this direction, divide by similarly, and for n1 it's xi1 minus xi2, but this is not it, we have eta direction as well. So along eta direction what we do is similar, eta minus, now instead of eta 2 we use eta for the fourth node, eta minus eta 4. Okay, eta minus eta 4 divided by eta 1 minus eta 4. That's it. Okay. Uh, for example, if we need to check, so let's, sorry, so let's check it. Okay. At node 1, what is xi comma eta? It is minus 1 comma minus 1. Let's put that value here. Okay. So xi is minus 1, and what is xi2? What is xi2? Xi2 is this. This is 1. Okay, divided by, and what is xi1? Xi1 is minus 1 minus xi2 is 1. Okay, into what is eta for node 1? It's minus 1 again. Minus 1 minus what is eta 4? Eta 4 is this 1 divided by what is eta 1? Eta 1 is minus 1, and what is eta 4? Eta 4 is 1, so minus 1. So as you can see, this is 1, and this is 1, so we get 1. It's okay. Similarly, you can do it for n2 as well. So for n2, if you have to look, then what you are going to do, for example, if you have to find the shape function for let's say for example node 2, this is our node 2, then what you are going to look, so the first direction you are going to look is along this direction. Okay, for the xi, and for eta you are going to look at this direction, and you are simply going to put the formula that it is xi minus xi1. Now xi minus xi1 divided by xi2 minus xi1, and for eta direction what you are going to look at is this direction, so it's eta minus eta 3 divided by eta 2 minus eta 3, and that's it. You can do similarly for all the nodes. So now let's extend this for 9 noded element. So for example, we have to find the shape function for node 1 here, n1 equals to, and as I already said that for node 1, which direction are you going to watch? You're going to watch along this direction for xi, okay, and along this vertical direction, along this direction for eta. Sorry, so along this direction for eta. Okay, for node for n1. So what you're going to do is for n1 it is xi minus, now xi along this direction xi minus xi2. We are still not finished. Again xi minus xi3 divided by xi1 minus xi2 and xi1 minus xi3 multiply by, now we have eta direction as well, so eta minus eta 4, this one, and then eta minus eta 7 divided by eta 1 minus eta 4, eta 1 minus eta 7, So let's check. Okay, so for check, for n1, what do we have? For n1, xi and eta are -1, -1. Let's put in this formula. So xi is -1 minus, what is xi2? So xi2 is 0. Okay, xi2 is 0. And again, xi is -1 minus, what is xi3? Xi3 is 1. 1 divided by, what is xi1? Xi1 is -1 minus, what is xi2? Xi2 is 0 -1 minus 1, because xi3 is also 1. So multiply by, now what is eta? Eta is also -1 here, and then minus, what is eta 4? Eta 4 is 0, and again eta minus eta 7. What is eta 7? Eta 7 is 1 divided by, what is eta 1? So eta 1 is -1 -1 minus 0 -1 -1, right? So what you get here is a similar terms. So this gives 1, and here also it gives 1. So it is 1. So it's okay. We are watching at this node, okay? This node, not 5. Then which direction are we going to watch? So first direction is this one for xi, okay? And for eta, we are going to watch in this direction, okay? So this is for xi direction, this is for eta direction. So for n5, what we are going to do is, so xi minus, so since xi is in this direction, so let's do xi minus xi4, xi minus xi4, and xi minus xi6 divided by xi5 minus xi4 and xi5 minus xi6. So multiply by, for eta, eta minus eta 2, and eta minus eta 8 divided by eta 5 minus eta 2 divided by eta 5 minus eta 8. So following this method, you can find the shape functions, all of them, n1, n2, n3, n4, n5. You can find all of them, and for each node, you will have the displacement values uv, let's say u1 v1, u2 v2, u3 v3, u4 v4, u5 v5, where u is horizontal displacement, v is vertical one. And once you find all the shape function, and for example our point of interest is at this point, for which there is some psi in eta. Let's say we need to find the displacement value uv at xi eta equals to, let's say, okay, 0.5 comma 0.5. It looks like 0.5 comma 0.5. So for finding displacement at this point, let's say for u displacement at that point at 0.5, you just need to do n1 u1, n2 u2, n3 u3, and so on and so on and so on until n9 u9. Here also you find up to n9, and you will have u9 v9, and similarly for particle displacement, just do similarly n1 v1, n2 v2, n3 v3 until n9 v9. So this is the purpose of finding the set function. Thank you.